So welcome to the Sine Law lesson. So we're moving into a new cycle here where we are starting to look at triangles again, but we are looking at slightly different triangles now. So if I want to show you here what we did already in the past, we looked at, Soka, Toa, and they were, I always referred to them as the trig ratios and so forth, okay? So what you had in common, the type of triangle that you always had a right angle triangle. So there was this little square, and then so therefore those two sides that touch the square would be an L shape, right? Um, so that's what we did before, and we would find the missing sides or the missing angles, um, and so forth, okay? But if you don't have one of these right angle triangles, so here is the triangle we're looking at now. So if you look at all the corners here, we don't have a right angle. So that means there's no 90 degrees. This one kind of looks like it, but we don't know for sure. It doesn't have the square there. Okay, so we need a rule or a law or equations, formulas that we can use when the triangle isn't a right angle triangle. So given a non-right angle triangle here, ABC, we need a new formula. Okay, so we're not going to use these old formulas here with SOHCAHTOA, TOA, right? Opposite over hypotenuse, adjacent over hypotenuse for cosine, and tangents opposite over adjacent. We have some new ones. So I would call these trig ratios, but the new ones I'm going to call sine law, and next day we'll learn about cosine law. Okay, so there's these two new formulas and rules that we have to follow, and it's because we don't have a right angle triangle anymore. Okay, so I just added the note here just to remind you, don't use SOHCAHTOA, TOA, so the opposite of hypotenuse. So you shouldn't be going in, putting a smiley face and labeling the sides as opposite, adjacent, hypotenuse, okay? So don't do that. Just kind of look for that first, right angle. Nope, it's not there. I'm not going to label the sides, stand somewhere. I'm not going to do opposite. Don't do hypotenuse. Don't do adjacent. What you're going to do instead is what we've kind of practiced earlier in the year is where you are going to label the sides with lowercase letters and the corners with capital letters, okay? So the sides, remember, it's like A, B, C, like that, so lowercase. And then the angles, normally we have them on the outside, like we have them out in the inside right now, so I could just write them out here. That's kind of usually where we write them, but so the angles are capital A, capital B, capital C. Okay, so those are the uppercase letters. So that was something we practiced at the beginning of the year. So I just wanted to bring that back up here. So you should know how to label things with opposite, hypotenuse, adjacent, all that stuff when it's right angle triangles, but when you don't have it, don't use this. So you can't use SOHCAHTOA, okay? All right, so don't be labeling any sides with opposite, adjacent, hypotenuse. Label them with little a. So see how this is capital A here. This is the angle A. It's looking at side A, so the side there is little a. This angle here, B, is looking at side B, so that's why that's little b here. This angle C here is looking at this side, so that's little c. Okay, so that's going to be important when it comes to labeling the triangle today. You need to be able to label the corners with capital letters, label the sides with lowercase letters, but then the letters have to match, right? The capital A has to match and look across at the little a. Capital B at the little b. Capital C is looking at the little c. All right, and the reason why is because we have these formulas here, sine law. It's one of the first ones we'll see this week. And you need to be able to, like if there is a number for A here, like 10 centimeters, you need to put that 10 centimeters here. Capital A will be the angle that's measured here. So you need to put the numbers in the right spot in order to calculate things. So it's kind of the same idea with what we did with SOHCAHTOA, but yeah, so it's so important to label things properly, okay? So we have these two new formulas. I know it looks a little overwhelming because they look like they're really complex, but they're not too bad. I'm going to provide them to you during assessments and so forth. So just know how to use them, okay? Okay, so we have a little note here saying that to use sine law, you need to have these conditions. You have to know one of the sides of the triangle and then its opposite angle. So if you know the side B, you'll know the angle B. So you need to have that condition, and then you need one more piece of information. It doesn't matter what it is. It could be an angle or side. So again, we're going to look at that in a couple days, where if I give you a question now, which law are you going to use? You have to figure that out, okay? But for today, we're just going to use sine law. So we're just going to practice going through, labeling the sides, and then calculating the missing side, okay? All right, so here's example 1. So you need to solve for the unknown side. So the unknown side in this case here is A, okay? So we have to find A. So from there, you're going to take a look and go, oh, I don't have a 90-degree angle here. Like, I don't know what that is, but I could figure it out, right? You know, there's 40 here, there's 65 there. So if you wanted to double check, okay, so these add up to 105. So this angle here then has to be 75, because you know angles in a triangle add up to 180. Okay, so we know that we don't have a right angle triangle. Okay, so from there, that means you can't use SOHCAHTOA. You're gonna, in this case today, we're just gonna use sine law here. So in order to use sine law, see how there's little a, b, c, and a capital A, B, and C. So you need to label the triangle with those different labels, okay? So when you don't know, you don't have any clues, you can just, you know, put A, B, C wherever you want. But here we have this one clue. So it's saying that this is side A. So therefore the angle that looks at it is capital A, okay? Capital A looks at side A. All right, the other two angles, it doesn't matter what you label them. Say I'm just going to call this one B and then call this one C. So triangle ABC. So angle A is looking at side A. Angle B is looking at side B. So B is 8 centimeters. Angle C is looking at this side here. Okay. All right. So from there, let's write out our formulas here. So there's two different ones here, if you take a look. They kind of look the same. What it is, you have like ABC at the top and then little ABC at the bottom here. So basically, these are the same, that you could just flip them. Okay, so we've seen that before in trig, where if we take one of them and flip them, we can flip them all and it's still okay to do that. So that's what's happened here, okay? So if you're trying to decide what you need to, which one should you use, I want you to look at, see how you have to find side A. So if you have to find the side, use the one on the left, because A is already up at the top, right? We don't like it when the number we need to find is at the bottom. That's always awkward and we have to flip things anyway. So if you want to find the sides, use the left, okay? If you need to find the angles, see the capital letters? If you have to find the angles, use this equation, okay? All right, so let's go through, and we need to find a side here, so I need this equation here. So I'm just going to write it out. Okay, so there's the equation now written out. I want you to go through and fill in as much as you can here, okay? So A, we don't know what it is. We'll keep it as A. Do we know the angle? A? Yes, we do. So that's 65 degrees. All right, little side B, do we know that? Yes. There it is. It's 8 centimeters. So write it in. And then we have angle B. So we know that's 40. So we're going to put that in. Okay. And side C, we don't know it. And then before I even wrote the 75 in, I didn't know what the C was either. Okay, I just knew that it didn't look like a right angle triangle. So I can leave it as C just because it wasn't there, but we did figure it out, so you can add in 75 as well. Okay, so here, why don't I just do that? So I'll put in 75. Okay, so again, what is our goal? We need to find A. So we definitely need this fraction here. So what you're going to do now is see that they're all equal to each other. We just need this A divided by sine 65 to equal one thing, okay? We don't need it to equal both of these. So see how I know the answer or the values for the top and the bottom of this one here versus I don't know C, okay? So then we don't want it where we have two unknowns. We don't even have to find C. We just need to find A. So what you're going to do here is you're going to now just rewrite this part of the equation again. Okay, and we're not going to worry about this because we don't need to find C. So from here, now it's a little easier. We just have to solve for A. So again, we have this here at the bottom, so I'm going to move it over here and multiply it on this side. So A becomes 8 times the sine 65, which gets thrown over, okay, because right now it's divided by A, so I'm going to multiply over here, multiply to the top, and then I'm going to divide by 40, sine 40. All right, so just a reminder, we need to be in degree mode, so if you can't remember how to do that, just let me know, email me, or I can meet you on Google Meet and so forth. So you should be in degree mode. There should be a DEG or D. If it's your cell phone, if it has nothing there, I believe it's degree mode. If it has rad, then you're in the wrong mode. Or some of your calculators can have grad on it, so those are all not good. Okay, so you need to be in degree. So I'm going to go through and I'm going to multiply 8 by sine 65 and hit equals, and then I'm going to divide by sine 40, and I will get side A is 11.2797, like that, centimeters, and I don't know if I told you to round. Oh yeah, round to 1 decimal place. So we're going to round this to 11 point. So see, it's 27. So I'm going to look at the next one here. 7 will round up the 3 to there, and then I'm going to write the units. Okay, and then you're going to take a look and go, okay, well, this side here was about 8 centimeters. We don't know what C was, and if this is about 11.3, that seems reasonable. All right, so I should be good here, okay? So if you get something like 100, all of a sudden, that's too far off. So I know these diagrams have to scale, but still, that's not really ballparkish with if the triangle has 8 centimeters like that. Okay, so that's the answer for that one, and you've now had your first example of sine law. Okay, so what you do, go through, label the sides, figure out which formula you're going to use, the left side one or the right side one. So again, if it's the little letters are at the top, that means sides. If capitals are at the top, that means it's a good formula to use for angles. Okay, but in the end, like if you ended up using this one by accident first when you're trying to find an angle, it's okay, it still works out. You just have to kind of have an extra step of solving. All right, so that one's done. Let's go to B now. So again, you're observing here, there's no little square in the triangle, so you don't know if it's a right angle. You can't assume it, okay? And even if you take the two angles here, 33 plus 41, it's 74, right? So if you take that away from 180, it's 106 in this corner here. Okay, so definitely not a 90-degree angle. So what you want to do from here is that, see how this is what you have to find? Okay, that's your unknown. So therefore, if that's your side C, the angle that looks at it is angle C. Okay, and then from there, the other ones, it doesn't matter. You can use any letter that you want, but it's going to use A and B. Okay, so angle A, B, C, or triangle A, B, C, that's what this is. So angle A is looking at this side, so that is side little a, and B looks at this side, so this is side B. Okay, so now that we have the sides and angles labeled, we need to determine which formula we want to use. So again, we need to find a side here, so I'm going to use the one on the left, okay? And again, I will give you these formulas, but it's always good, just write them out every time you're doing your homework questions, and you get them memorized, and then you don't have to waste time looking for it on the formula sheet, writing it out, and so forth, okay? All right, so now that we have the formula, let's fill everything in. So side A, we know it, it's 15. Angle A, yep, it's 41 degrees. Side B, don't know it. Angle B, could find it, but let's just say we don't know it. C, we don't know it, but we need to find it. And the angle C is 33 degrees. Okay, so again, this is the formula that's being presented, but you don't have to use every piece of the formula, okay? So we need to find C, so this part of the formula is important. This one here in the middle doesn't have any information. We don't know side B. We don't know angle B. We could find it, but we don't know it right explicitly. So I wouldn't use that one there. Okay, you just take that one out, the one that's not useful for you. But here, this one, you know both the top and bottom values, so that can be equal to the ratio here where you need to find C, so you can equal it to there, and then we don't need to write this middle one again, okay? So you can just get rid of it. All right, so again, if you do need to find it, then you can make a separate equation after, but for now, we just need to find C. All right, so from here, it's just a solving step, right? So we have sine 33 divided, so I would boot it over here, and I would write it as 15 times. Okay, remember you throw it to the top. See, it's divided right now. Throw it to the top on the other side. Okay, and then divide it all by sine 41. Okay, so yeah, so let's just calculate this out. And C becomes 12.45251, etc. Okay, and do we have any units this time? Nope, we don't know, but we want to round it to one decimal place here, so we're going to keep this one, and we have to look at this one to determine if we're going to round up. So it becomes 12.5, and we don't have any units, so I'm just going to write units. Okay. All right, so there was the next one where so both of these you had to find the missing side, and so we used the left formula here to find the side. Okay, so people generally, they find triangles, trig, all really nice and just easy ways to just easy to learn. So just kind of practice these. Get, you know, the only problems I can see here is if you put the number in the wrong spot of the formula, but otherwise you can be very successful with this section. Okay. All right. So that was example 1 where we're finding the sides. So now we're going to go to example 2. Well, what if we have to find the angle? Okay. So we looked at that already. We have a formula here that you want to use. Again, it's just this one flipped over when we have to find angles. But again, before we do that, we need to label the sides. All right, so again, when you don't have anything labeled, you could just kind of write in letters. And even if it has different letters, you should be able to use those formulas the same way. Yeah, so it's going to go from there. So we need to find the angle that's unknown, okay? So if you're like, whoa, which angle is that? It's this one here. Okay, this one's labeled find angle A. Here, we're looking at, you know, we know angle C here, but we need to find both A and B here. Okay, so we need to find both of these. All right, so let's just start with this one here. We're going to label the sides. Okay, so we have angle A, we don't know, but because it's looking at this side here though, that's side A. The other ones, it doesn't matter what you label them, so I can call this one B and this one C, okay? So angle B is looking at this side, so this is little b. And angle C is looking at this side, so this is little c. All right, so again, this is about finding the angle this time, so I'm going to use the formula that was on the right. So I'm going to put the capital letters at the top, the little lowercase ones at the bottom. The capital letters are always with sine. Whoops, B. Lowercase b. Okay, and the sides are just on their own like that, okay? All right, let's fill it in. Angle A, we don't know it, so I'm just going to leave it as sine of A. Side A is 7. Sine of B is 67 degrees, so I'm just going to fill the B in with the angle. And then side B, little b here, is 24. Angle C, I don't know it. Whoops. Don't know it. And side C, I don't know it. So again, so now it's just a matter of, here is an equation where yes, you have three things equal to each other, but you don't need to use all of them in order to get to your answer. So again, the one that you don't know any information about, even if you could find it, so this isn't going to be helpful right now, so we don't use that one. But these two will help you because you know both of these, top and bottom. You know the bottom of this. So you just have this one that's unknown that you have to solve for. Okay, so I'm just going to rewrite them without that third ratio. Okay, so there it is. So from here, you're going to solve and find the angle A. Okay, so step one here, you're going to get that 7 out of there first. Okay, so you're just going to boot it over there. So I'm going to go 7 times sine 67. So we're going to multiply it up to the top. We're not going to calculate this yet. So then right now we have the sine on here on A. Remember, we want A by itself, okay? So how do we get sine out of there? Well, do you remember when you did this before with the trig ratios? The opposite, because the opposite of divide 7 here is to multiply 7, so we kicked it over. So what is the opposite of sine? The opposite was, remember, the inverse sine, okay? So you're going to take the inverse sine of all the stuff that was over there. So make sure that you're using your brackets and so forth on your calculator. So again, make sure your calculator is in degree mode. I just grabbed a calculator here. I downloaded one online. It's all right. It's almost, it's a Casio. I don't know. I think there's a lot out there, but this is the first one I found. I downloaded it. Anyway, you got to tweak it a little bit to get it into degree mode and do all this stuff. But once you can get it working, it works great. So let me know if you want instructions on how to download this. But for now, I just want you to be able to see what I'm typing in when I'm going through and calculating these, okay? So on your calculator, if you have a scientific one, you generally you'll see like a sine, a cosine, and a tangent buttons here. So again, we need the inverse tangent. So if you take a look at my calculator here, it says AS and ACS. So this is just, sometimes they write arc sine, arc cosine, arc tangent. So, or like what you'll see on your most of your calculators is sine -1, cosine -1, and so forth. So you just have to hit shift and hit the sine button in order to get to the inverse, okay? So I'm going to do that here, shift, and then, so see when I do that, I actually get the sine -1 on the calculator, okay? All right, so use lots of brackets here. So I want to take, so I'm going to use a couple brackets here. I want 7 times sine, just regular sine, right? 67. And again, I know that I'm in degree mode here, DEG, you'll have a D, and so forth on your calculator. If you have rad or grad, those are wrong. All right, so 7 times sine of 67, and then I'm going to go divided by the 24, and then I'm going to close the bracket up and then hit enter here. Okay, so I get 15.57, and then again, the whole point whenever you do the inverse, it's because you're finding the angle, so write degree. And it says to the nearest degree, so round to the nearest degree, so that means round to the nearest whole number here. So I have a 5, oops, I have to keep this 5, so I'm looking at the next number and going, oh yeah, that's 5, or, or if it's greater than 5, you need to round up, so this becomes 16 degrees. Okay, so the angle in here is 16 degrees, that one's 67, and then if you had to find the next angle, then the triangles and an angle add up to 180. So even though this isn't a right angle triangle, that rule still applies. They should all add up to 180. Okay, so now you've seen one with where you have to find the angle. You remember the two above here where the side was missing? Okay, so here's one where the angle is missing. So this new sine law formula that we have can help you find sides, but they can also help you find the angles as well. Okay, all right, so let's get to the next one here. We have a couple of sides missing here. So we have to find them both. Doesn't matter which one you find first, but just let's get everything labeled. Okay, so again, the C's in here, but if you want, you can put it out here. Angle C is looking at little c, so this is side C. Oh, that C looks just as big. Okay, and then angle A is looking at little a, Angle B is looking at side B, like that. Okay, and because we have to find the angles here, I'm going to use the formula where the capitals are up in the air, okay, or up at the top. So sine of A, little a's at the bottom, sine of B, little b's at the bottom, okay? So since you've had to write these over and over again, hopefully you already have these memorized, okay? But again, don't worry about it. I will have them on a sheet as well, but it's always good to just write it out. Okay, so sine of A. A is, we don't know, okay? So I'm going to leave it A. Sine of, little side A, don't know it either. We have sine of B. Okay, B, I don't know that angle either. And we have a side B though, 4.7. And we have sine capital C. We know that is 63 degrees. And little side, the side C is 5.5. Okay, so this is kind of, I don't know, this is the important one here because we know both the top and bottom values. This one here, we know most of it, okay? And A, we don't know anything, okay? We have to find it eventually, but it's not going to be useful when we don't know both letters, okay? So what we're going to do here first, we're going to go find B first because we have more information to help us find B before A, okay? So we'll just go find B first. So if we write it without the A, okay, so from there, let's boot this over here. Okay, so it's divided by 4.7 right now. So when I throw the 4.7 over, I'll multiply it over on this side. Okay, and then before I go through and calculate all this up, I want to get the sine off of there as well. So we'll boot the sine off. And when we do that, the opposite of sine is inverse sine of all of this stuff. Okay, so let's use our calculator again. So we have, let's see here. Okay, 4.7, or inverse sine first. So shift inverse sine of, and I'm going to go a couple brackets again, 4.7 times the sine of 63. Okay, and then bracket divided by 5.5 bracket. Okay, so here I have inverse sine 4.7 times sine 63 divided by 5.5. Okay, and I don't know why I wrote this second bracket so small. Let's make it bigger here. Okay, so let's calculate that out now. So we have, enter, 49.588, okay? Okay, etc. And again, because we did the inverse, we needed to find the angle. So there's B, okay? So we found one of the angles, but we need to find A as well. I'm not going to round up B yet because we still have to find something else here, A. Okay, so remember, round up at the end when you're finished the question. So A, so if I write that in now, I know that B is 49.58. So 49.59, I guess. Okay, so we know it's 49.59 degrees. We know this one's 63, so what does A have to be? Well, A, you're going to go 180, because the whole thing adds to 180. Then you're going to take away this 49.59, and you're going to take away the 63 degrees, which we already knew from the beginning. And then what's left is what A has to be. So let's calculate that out. And we get 67.5 0.41 degrees, like that. Okay, so now that we have the answers, we can round up to the nearest degree, so to the nearest whole number here. So keep this, bump this up. So 49 has to round up, so the next number is 50 degrees. And then this one here, we need to keep the 7. We look at the 4. 4 is not 5 or greater, so we keep it at 67 degrees. Okay, and so now you've finished ones where you have to find the angles using sine law, and you finished the ones where you need to find the missing side using sine law. So again, these triangles are different from what you've done before in the sense that they are not right angle triangles, so you can't use SOHCAHTOA. You have to use this formula instead to go and find the sides and angles like you did before, okay? But you have to, again, labeling the sides A, B, C, little a, little b, little c, instead of writing opposite, hypotenuse, and all that stuff, okay? All right, so let's get to this last example here. Okay, so here's the last example now. So we are building a roof on a house here, and we want to put some solar panels on. So we need to build the roof according to these specifications here. So the long rafters, which is this part here, has to be a 26-degree angle from the horizontal beam, which is right here. Okay, so the 26-degree angle. The short rafters on the back, which are here, they have to be a 66-degree angle, okay, from the horizontal beam, okay? So, and then we know one more piece of information. We know that the house is 15.3 meters wide. Okay, so knowing this information here, we need to determine the length of the long rafters here. So if you take a look here, you know, thinking maybe this corner is a 90-degree angle. If you do double check by going 180 minus 26 minus 66, it's a 88-degree angle. So it was close, but it's definitely not a 90-degree angle here. So we don't have a right angle triangle. So what we're going to do today is then we're going to use, because we're learning about sine law, we're going to use the sine law today. Okay, so I'm going to just draw this out separately from the picture here so that we can kind of get a good view of the triangle here. Okay, oh, sorry, that's just a wobbly triangle. So we don't have a right angle triangle, so don't use SOHCAHTOA. We know we have a 66-degree angle in this corner, we have a 26-degree angle in this corner, and we have this one measurement here at the bottom for the horizontal beam. Okay, and that's all the information we are given. They're asking us to find the long rafters here. So we can call that, you know, X or whatever letter you want to use, okay? We're going to use our new formula in order to find the side. In order to do that, we need to label our triangle here. So in this case here, there's nothing labeled, you know, like there's no A, B, or C. So it's up to you what you want to, how you want to label it. So you can just do it randomly here. So I'm just going to go A, B, C, like that. So A looks across here, there, and then C looks across here. So instead of calling this X, I guess we can call it C, all right? And this is little b here, okay? All right, so get a diagram. So sometimes when you have a diagram like this, just kind of write it separately. So just the essential information is here, so it's a little easier to visualize, okay? All right, so because we have to find the side, we're going to use the formula where the little letters are at the top, okay, the lowercase letters. So the capital letters with the sign will be at the bottom. Okay, there you go. All right, so let's go fill it in. Okay, so little a we don't know. Leave it as A. Sine of A we know is 26 degrees. Sine of B, or sorry, little b is 15.3. Capital B we don't know. Lowercase c, the side C, we don't know. We need to find that. And then angle C we know is 66 degrees. Okay. All right. So just like the questions that we did before, we always had one ratio where we knew both the top and bottom, but we have too many letters in this case here, so we can't solve it. So what we need to do here is remember how we can always find that third angle when we're given the two angles here. So let's go and do that so we can actually go through and solve this. So this angle here, you're going to you know the angles in a triangle, regardless of what triangle it is, will add up to 180. So we're going to subtract the 26 and the 66, and we will get the angle, the third angle, and that'll be 88. Okay, so which we looked at already from before because we were trying to figure out if this was a right angle, and it wasn't, okay? All right, so now that we have our angle B, we can actually fill it in here. So I will erase this B here, and I'll put in 88 instead. So now I have one where I know both the top and bottom numbers, and then I have this one here. So I can use just these two in order to find my answer, okay? So I don't need to use this one here. So let's rewrite it. Okay, and just think of one more thing here. Remember how you use Pythagoras to find the missing side? You always need a couple sides in order to use Pythagoras, but if you don't, if you happen to have two sides here, in this case, you still can't use it because you don't have a right angle triangle. Okay, so right angle triangle, SOHCAHTOA works, Pythagoras works, but if it's not a right angle triangle, don't use those rules there, okay? All right, let's solve for C. So let's boot this sine 66 out of here, put it on the other side. So since it was divided, we're going to multiply it over here. So multiply it to the top. And then we still have the sine 88 at the bottom, but we have isolated C here. So let's go through, make sure your calculator's in degree mode. And we're going to go through and calculate this out. Okay, so I'll just clear this stuff out of here. Okay. Oh, okay, there we go, delete, get that all out of there. Okay, so now we have 15.3 times the sine 66. I'm gonna hit equals, okay, and then I'm gonna divide by the sine 88 equals, and I'll get 13.985, 985, there's some other digits there. And what are we finding here? We're finding the length in meters. And I don't know, does it say to round to 2 decimal places? Okay, so we want 2 decimal places, so we want to keep this spot here. We're going to look at this one and go, yep, we have to round that up. So 13.99 meters. Okay, all right, so since this is a word problem, we're going to make a final statement here. We're going to say, therefore, the length of the long rafters that they're going to put the solar panels on, okay, length of the long rafters is 13.99 meters. Okay, so yeah, so again, just make sure, go through, you know, read the problem, make sure you understand it, make sure which side you need to find, make a diagram that's kind of doesn't have all this other information on there like the trees and the rest of the house, and then go through, label the sides and angles, and then use the formula, fill it into the correct spots, everything. Make sure that's really key. People, like, this isn't too bad of a concept, but people don't put the values in the right place, okay? So make sure the little letters are the sides, the capital letters are the angles, and sometimes you just need to go and find that third angle, okay? So go and do that so you can solve the problem here, and then make sure you're in degree mode, and then calculate your answers out, okay? All right, so go and practice some questions, and make sure you can find the sides, make sure you can find the angles, and then once you're good, go and try the checkpoint.